The Cafferty Group Technical Service Advisors, with offices located in Nebraska, Iowa, Kansas, and Colorado, presents the Daikin FIT R32 Installation and Commissioning Technical Training Module, TRV 13.2, Installation and Commissioning. Disclaimer: this material provides technical information that is to only be used by appropriately trained and certified HVAC/R installers and technicians who have agreed to the terms and conditions that are available at https://www.daikincity.com/daikincitybtb termsofuse.html. If you have not agreed to these terms and conditions, you may not use or view this material, and you assume responsibility for any injury or property, system, or equipment damage that may result. If you agreed to these terms, you also agree by viewing or using this material that this material, by its nature, cannot include a discussion of everything necessary to effect a proper installation or repair of HVAC/R equipment, nor can it address every possible scenario or environment a technician or installer may encounter. Accordingly, this material should not be considered as recommendations for best practices and will not be considered installation or repair instructions to the extent of any conflict with Daikin or Goodman issued manuals and specifications, or industry standards and regulations. Each installer or technician remains fully responsible for ensuring proper installation or repair of the HVAC/R equipment being worked on, and you remain fully responsible for any injury or property, system, or equipment damage which may result from your installation. Copyright 2024 Daikin Comfort Technologies North America Incorporated. All rights reserved. Recording, copying, or distribution of this material is prohibited without express written permission from Daikin. Training Agenda: Pre-installation, Installation, and Commissioning. Let's start with pre-installation. Outdoor unit location considerations. Always follow the instruction manual for equipment clearances. Improper outdoor unit placement can cause adverse operation of the equipment, for example, short cycling, defrost, etc. Do not stack more than 2 units and leave at least 20 inches vertical clearance between the outdoor units. Sound vibration transmission should be considered when installing the outdoor unit. Ensure that the roof structure can support the weight of the unit. Refer to the specification sheet for outdoor unit weight. Proper consideration should be given to the weather-tight integrity of the roof. Wind baffles can be used to help limit air recirculation when there is a wall facing the outlet and no top. Electrical noise. The inverter units should be well grounded. This prevents the potential effects of electrical noise from the inverter to surrounding equipment. Keep enough distance from home stereos, personal computers, solar panel control boxes, whole house generators, etc. At least 60 inches. Biflow filter dryer. A biflow filter dryer is shipped with a unit as a separate component. If the paint of the steel filter dryer has been burned or chipped, repaint or treat it with a rust inhibitor. The recommended location for the filter dryer is before the expansion device at the indoor unit. Inclement weather conditions. When operating the air conditioner in a low outdoor ambient temperature, be sure to follow the instructions described in the installation manual. Install the unit so that the bottom of the frame is a minimum of 19 3/4 inches higher than the expected snowfall. If possible, construct a canopy over the top and elevate the units by using a wall mounting bracket or pedestal. Consider wind exposure. Install the outdoor unit with its inlet side facing the wall. Install a wind baffle plate on the air discharge side of the outdoor unit. Never install the unit at a site where the inlet side may be exposed directly to the wind. Below, see the chart showing the available options for snow guards. Cold climate operation. Drain pan heater considerations. A drain pan heater is available when the unit is installed in a climate where the drain may freeze. It is highly recommended that you use a drain pan heater in areas where the outside air temperature drops below 32 degrees Fahrenheit for more than 12 continuous hours. Only utilize the existing holes for drainage. Remove the rear inlet grill to prevent snow from accumulating on the rear fins. Double fan equipment does not require a drain pan heater accessory. Removing the transport bracket on double fan models. A yellow transport bracket and washer are attached to the leg of the compressor to protect the unit during transportation and must be removed before starting the system. Open the soundproof cover that is wrapped around the compressor, but do not remove it from the compressor. Remove the securing nut. Remove the transport bracket as shown in the diagram. Retighten the securing nut and return the soundproof cover as it was. Now let's discuss installation. Piping diagram. Large chassis heat pump. Thermistor locations can be used to plot data that is identified on the D-checker. Please refer to the unit-specific service manual for piping diagrams. Here is a piping diagram example for double fan models. Insulating refrigerant lines. The gas line must always be insulated between the indoor and outdoor units to prevent condensation from forming. The liquid line must be insulated if more than 50 feet of liquid line will pass through an area that may reach temperatures 30 degrees Fahrenheit or more above outdoor ambient temperature. Insulation must be installed in a manner which protects the tubing from damage and contamination. Insulation with 3/8 inch wall thickness is recommended. In severe conditions, hot, high humidity areas, 1/2 inch insulation may be required. Piping support. Tighten brackets so that they hold the pipes in place but still allow for expansion. If hanging the line set from a joist or rafter, use metal strapping or heavy nylon wire ties that are securely anchored. Applications greater than 80 feet of refrigerant tubing is prone to transmit noise and vibration to the adjoining structure. Use adequate vibration insulating hardware when mounting the line set to the structure. Existing refrigerant lines. Drain as much residual compressor oil from existing line sets and traps as possible. Pay close attention to low areas where oil may collect. If changing refrigerant or using existing line sets, you must flush the existing refrigerant lines. Use a professional flushing agent to remove any excess oil or debris left by the prior HVAC system. Legacy oil drainage and passive nitrogen flush recommended. Refrigerant piping requirements. Single fan models. when the outdoor unit is mounted higher than the indoor unit. Maximum line set equivalent length is 125 feet. Maximum actual length is 100 feet. Maximum vertical separation between the outdoor and the indoor unit is 100 feet. The equivalent length includes pressure losses of any elbows, bends, etc. When the outdoor unit is mounted lower than the indoor unit, the refrigerant lines require an inverted loop in the suction line near the connection to the indoor unit. This prevents liquid refrigerant migration to the outdoor unit from the indoor unit. The top of the loop must be higher than the top of the coil. Maximum line set equivalent length is 125 feet, which includes pressure losses from any elbows, bends, etc. Maximum actual length of the line set is 100 feet, with a maximum vertical separation of 90 feet. Refrigerant piping requirements for the double fan models. When the outdoor unit is above the indoor unit, maximum line set equivalent length includes pressure losses with any elbows, bends, etc. On the double fan model, you'll see that the maximum equivalent length is, on the 3-ton for instance, 187.5 feet, with 150 feet actual line set length, with a maximum vertical separation of 100 feet. If the outdoor unit is mounted below the indoor unit, again for the 3-ton, maximum equivalent length is still 187.5 feet, maximum vertical separation 90 feet, actual line length 150 feet. Connecting refrigerant piping to the double fan models. Here you'll see the front panel, the pipe outlet panel that covers the front, side, and the back. You do have back connections, side connection, bottom connection, and front connection. Knock out the back connection knockout hole. After knocking out the knockout hole, it is recommended you apply repair paint to the edge and surrounding surfaces to prevent rusting. Connection from the stop valves to the field piping can be done by using the supplied field connection piping kit. Ensure that the field connection piping does not come in contact with other piping, bottom frame, or side panels of the unit. Back connection, which is the recommended connection. Insulate the liquid and gas pipe using the supplied insulation. To prevent the bends of the pipe from being exposed, wrap them with vinyl tape over the insulation. The supplied gas line insulation will not reach the stop valve and must be completed with field supplied insulation. After the piping work is complete, seal the knockout hole with field supplied putty. Remove the valve cover and make sure that the stop valves are fully closed. Be careful when removing pinched piping. Piping may be under pressure. Cut off the lower part of the smaller pinched piping just above the braze point, or mark it with an appropriate tool such as pipe cutters. Brazing. Preparation for brazing. Remove Schrader cores from the service valves before brazing the tubes to the valves. Using a brazing alloy of 2% minimum silver content, 15% is preferred, and do not use flux. Wrap the valves with a wet rag or heat gel to prevent damage to the valve. If the biflowed filter dryer paint is scratched or burned, corrosion may occur. Brazing with nitrogen. Dry nitrogen must be used during brazing to prevent oxidation formation. Step 1. Leave the opposite end of the tubing open so that the nitrogen can exit during brazing. Step 2. Set the nitrogen regulator to 20 psig to purge the line set for 15 to 30 seconds. Step 3. Set the nitrogen regulator between 1.5 and 3 psi and sweep the refrigerant lines while brazing. Step 4. After brazing, quench the joints with water or a wet cloth to prevent overheating of the service valves and filter dryer. Pressure test. Nitrogen pressure testing considerations. Nitrogen pressure is subject to fluctuation based on ambient temperature changes. The following formula will determine system pressure drop caused by low ambient temperatures. Use the formula to compensate for temperature changes from one day to the next when performing the pressure test. Record the temperature when the system is pressurized. Subtract the temperature when the pressure is checked. Multiply by a factor of 0.80 to get the pressure drop. This applies to nitrogen pressure over 300 psi. When performing the nitrogen pressure test, it is recommended that you pressurize the system to 150 psi and allow it to stand for 3 minutes. Increase the pressure to 325 psi and allow that to remain for 5 minutes. Then increase the pressure to 450 pounds and leave that in the system for a minimum of 1 hour. After the pressure test has verified that there are no leaks, a triple evacuation should be performed. Step 1. Evacuate the system to 4,000 microns and hold for a minimum of 15 minutes. Step 2. Break that vacuum with dry nitrogen to a pressure of 2 to 3 psi and hold for 20 minutes. Step 3. Evacuate to 1,500 microns and hold for 20 minutes. Step 4. Break that vacuum with dry nitrogen to a pressure of 2 to 3 psi and hold for 20 minutes. Step 5. The final evacuation should be below 500 microns and hold for 60 minutes. When the evacuation is complete, use the last vacuum to pull the additional refrigerant charge into the system, calculated by line set length if it's over 15 feet. The triple evacuation is the only way to ensure a clean, dry, and sealed line set. Triple evacuation tools. Vacuum-rated hoses. Vacuum-rated hoses must be used to ensure a proper system vacuum. The red, yellow, and blue hoses that come with your gauges are typically not vacuum-rated. The larger diameter hose equals a shorter evacuation time. Vacuum pump. Having a properly maintained vacuum pump is important for evacuating a refrigerant system. Pump capacity should be a minimum of 2 CFM 2-stage. Check the valve in the vacuum pump. Micron gauge is a vacuum gauge with a digital display. Using a micron gauge for the entire evacuation process is mandatory on all systems. And a vacuum-rated core removal tool. Removing the Schrader core increases the diameter of the valve access port, reducing the amount of time needed to evacuate. Gives you reduced leak points compared to the manifold. System evacuation. Some pumps come with 3/8 or 1/2 inch hose connections on the pump. By connecting larger vacuum-rated hoses and removing the Schrader cores, evacuation will be faster and more complete. Attach a micron gauge at the port of the core remover. With this connection, there is no need for a manifold. Voltage separation requirements. Voltage separation is a requirement per UL 1995. High voltage, which is main power, compressor and fan power, power to sub-boards, and power conditioners. Low voltage is all sensors, communication cables, including thermostat cable. Maintaining wire routing after servicing any inverter air conditioner is very important. Before touching the inverter board, power down the unit and verify that the measurement between C positive and C negative is 50 volts DC or less. Printed circuit boards on small chassis units. The main printed circuit board. Here are the connection locations for the solenoid coil for the heat pump, condenser fan, compressor, terminals U, V, and W, outdoor electronic expansion valve, low pressure sensor, ambient thermistor, defrost and coil temperature thermistor, high pressure switch. On the service printed circuit board, here's the D-checker port, the shared data port, 7-segment display, dip switch 2, dip switch 1, and data connection. Printed circuit board on a large chassis unit. Reversing valve solenoid. Dip switch 1, dip switch 2. Data connections. Thermistor bank. Outdoor unit electronic expansion valve. High pressure switch. Low pressure switch. 7-segment display and push buttons. D-checker port. Shared data port. Compressor terminals. Condenser fan. Label for the inverter printed circuit board components on a 3.5 to 5 ton unit. D-checker port. Shared data port. Dip switches. Thermistor bank. Outdoor fan motor. 7-segment display and push buttons. Data connection. Compressor terminals. Reversing valve solenoid. Outdoor unit electronic expansion valve. Low pressure switch. High pressure switch. Voltage monitor and surge protection. We highly recommend the use of a voltage monitor and surge protection to protect the equipment from any voltage fluctuations or electrical power surges. Warranty does not cover unit damage or failure of the unit starting up due to an interruption or insufficient electrical service. On the chart below, you'll see that an EEV air handler and modular blower, which operates on 208 to 230 volts AC, will operate from a minimum of 197 to a maximum of 253 volts. The EEV air handler and gas furnaces that are 115 volts will operate from a minimum of 103 to a maximum of 126 volts. EEV cased coils, which operate on 24 volts, will operate from 22.6 volts to 25.5 volts maximum. The outdoor unit, which is 208 to 30 volts, will operate from 197 minimum to a maximum of 253 volts. High voltage wiring. The unit rating plate lists pertinent electrical data necessary for proper electrical service and overcurrent protection. Wires should be sized to limit the voltage drop to 2% maximum from the main breaker. Do not install the switch on the unit. Local codes often require a disconnect switch be located near the unit. 3.5 to 5 tons have an optional knockout to route the high voltage wiring. Minimum circuit ampacity and maximum overcurrent protection charts are found in the installation operation manual. When using residual current operated circuit breakers, be sure to use a high-speed type, 0.1 second or less, 200 milliamp rated residual operating current. Use copper conductors only and insulated power wires. Select the power cable type and size in accordance with local codes. This chart shows the model name, the phase and frequency of the system, the voltage, the minimum circuit ampacity, the maximum overcurrent protection, and the communication wire selection. Route the power supply and ground wires through the high voltage port and terminate in accordance with the wiring diagram. Connect 208 230 volt 60 Hz field wiring to the terminal block located in the electrical panel. Electrical wiring for double fan model units. Route the power supply and ground wires through the high voltage port and terminate in accordance with the wiring diagram. Connect 208 230 volt 60 Hz field wiring to the terminal block located in the electrical panel. Route control wires through the low voltage port and terminate in accordance with the wiring diagram. Daikin thermostats. The Daikin 1 Plus Smart Thermostat and the Daikin 1 Touch are the approved thermostats for the Daikin FIT system. Thermostat location. Do not install the thermostat where it can be affected by drafts or dead spots behind doors and corners, hot or cold air from ducts or ceiling fans, radiant heat from the sun or appliances, concealed pipes or chimneys, unheated or uncooled areas such as an outside wall. Installing the thermostat. Mount the thermostat to be leveled, approximately 5 foot from the floor, on an interior wall using the included screws. Seal the hole made for wiring pass-through. Low voltage wiring. Communicating wiring detail. If the low voltage requirements are not met, check or eliminate wiring connections, crossed wires, loose wires, broken wires, etc. Replace the wiring. Using 18-gauge stranded shielded wire is recommended. Move dip switch 1 switches on the outdoor printed circuit board to the opposite position. Wiring detail when pairing with an air handler. Minimum of 18-gauge AWG. Maximum of 125 feet between communicating thermostat and indoor units. Maximum 250 feet between the outdoor unit and the indoor units. 4 wires from the indoor unit to the coil printed circuit board to the thermostat. 2 wires is required from the indoor unit to the outdoor unit. Low voltage wiring to a furnace with R32 sensor capabilities. Data line 1 is shown as a black wire. Data line 2 is the gray wire. R, the 24 volts hot, is the red wire. C, 24 volts common, is the blue wire. Notice that between the thermostat through the coil to the furnace is a maximum of 125 feet. The communication line is all that's needed between the furnace and the outdoor unit, and that would be a maximum of 250 feet. Low voltage wiring for non-A2L compliant furnaces. The leak detection sensor must be wired directly to the non-A2L furnace integration kit and installed as a pass-through to the non-A2L furnace control board. EWC UT3000 Zone Control. The UT3000 controls up to 3 zones on a single board. Up to 5 zones twinned using 24-volt power open and closed motorized dampers. EWC zoning complies with Manual ZR, ANSI, and ACA 11 Manual ZR 2018. When paired with EWC, you must set lockout temperatures from the UT3000 zone control board menus. You must set zone weights from the UT3000 zone control. Default settings are as follows. 3-zone, 70%, 15%, 15%. 2-zone, 60%, 40%. Connection points using communicating thermostats in all zones on the UT3000 zone control system. The 24-volt power input. ComfortNet air handler or furnace. ComfortNet condensing unit or heat pump with the outdoor air sensor. The 3 thermostats. Supply air sensor. Damper 1, 2, and 3 connections. The zone panel will interpret the digital thermostat demands and stage or modulate the communicating HVAC system to meet the demands of each zone. The EWC UT3000 Zone Control plus the new Distributed Air Pressure Controller, DAPC. The DAPC module can monitor the system static pressure and send the UT3000 open and close damper commands. When the static pressure gets too high, the DAPC will modulate the closed zone dampers toward the open position to control static pressure. The DAPC's default static pressure set point is 0.5 inches of water column. Static pressure set point can be adjusted from the DAPC module between 0.15 inches of water column to 1.5 inches of water column. Customize and let the DAPC discover the actual non-zoned static pressure of your system and adopt that value as the static pressure set point. Add equipment zone board, zoning mode, and circulation selection. The zoning mode will be automatically turned on, and the circulation selection will be automatically turned off when adding an EWC zone board through Equipment Setup, Add Equipment, Zone Board. Zoning mode allows the system to run with lower indoor airflow compared to normal operation when the cooling or heating demand is low. Circulation selection can be turned on and off to avoid automatically increasing the indoor CFM by circulation control. When on, the system may increase indoor CFM to circulate indoor air when the outdoor unit detects a low evaporative temperature. When off, the indoor CFM will not increase even if the outdoor unit detects a low evaporative temperature. This is recommended for zoning applications. So on the zone equipment setup, click on Add Equipment, Zone Board. Additional equipment will show as Zone Board and then Circulation Selection, on or off. Zoning Control Accessory Board. From the Indoor Unit Control Board, wire the common terminal to the Zone Controller Power on the Zoning Control Accessory Board. Wire the normally open to T1 on the Zone Control Accessory Board. The wires from the Zone Power connection on the Zone Control Accessory Board should be routed to the P and C terminals for the 24-volt transformer on the EWC Zone Control Module. The 24-volt transformer should also be wired to terminals P and C of the 24-volt transformer terminal on the EWC board. Wires should also be routed from the zoning control accessory board, terminals Zone 1, 2, and 3 in, to the EWC control module damper connections 1, 2, and 3. Terminals R and C and communication wires 1 and 2 should also be routed from the indoor unit control module to the EWC control module, terminals C, R, 1, and 2. Wire the 3 zone controllers to terminals C, R, 1, and 2 on the EWC control module. Then route wires from the zoning control accessory board, terminals Zone 1, 2, and 3 out to the 3 damper motors for zones 1, 2, and 3. Charging the system single fan models. Calculate refrigerant charge. The outdoor unit is shipped with a predetermined factory charge level. The installer must measure the new or existing line set length and diameter for the best charging calculation. Charging tables are provided in the installation operation manual based on indoor coil and line set length and diameter. The total refrigerant charge, A, is equal to the factory charge, B, and the additional charge for the line set, C. Note, beyond your calculated charge, not more than 0.5 pounds or 8 ounces of refrigerant must be added to the system to achieve the target subcooling. It is recommended that you add 1 ounce of refrigerant each time and let the system stabilize for 10 minutes. On the single fan model's charge table found in the installation operation manual, look at the column for the size AC or heat pump, the indoor unit type, the liquid line diameter, the suction line diameter, actual line set length in feet, and compare it to the chart below to determine your additional and total charge. Charging the system double fan models. Calculate refrigerant charge. The outdoor unit is shipped with a predetermined factory charge level. The installer must measure the new or existing line set length and diameter for the best charging calculation. Charging tables are provided in the installation operation manual based on line set length and allowable line set diameter. Total refrigerant charge, A, equals the factory charge, B, plus the additional charge for the line set, C. Note, beyond your calculated charge, not more than 0.5 pounds or 8 ounces of refrigerant should be added to the system to achieve their target subcooling. It is recommended that you add 1 ounce of refrigerant each time and let the system stabilize for 10 minutes. Double fan model charging table is shown on the right. Find the allowable line set combinations listed in the installation manual and verify the line set selection based on the tonnage of the outdoor unit. Go to the charging chart in the installation manual and charge the system based on the line set length and verified allowable line set diameter. This chart shows the allowable combinations of liquid and suction line for 2-ton, 3-ton, and 5-ton systems. Let's do an exercise. We will determine the following information using the I.O., assuming the liquid line is 3/8 inches and the suction line is 3/4 inches. In this example, all 90-degree elbows are long radius. For this exercise, we will use the DH6VSA24-1A outdoor unit and the CAPEA2422B3 indoor air handler. This chart shows the inside diameter of the long radius 90-degree elbows. Trying to reach a target subcooling of 8 degrees, we see here that our line set total length is 54 feet 2 inches. The line set vertical elevation, you'll see 14 inches vertical on the liquid line at the outdoor unit, and another 8-inch vertical difference on the liquid line going into the indoor unit, for a total of 22 inches or 1 foot 10 inches. We can see in the I/O manual and on the outdoor unit data tag that the factory charge is 73 ounces. Using the chart that we had just looked at, we calculate the additional charge to be 26 ounces, which gives us a total charge of 99 ounces. Now let's do the exercise using a 2-fan 3-ton system. We will be using the DH9V SA36 1A outdoor unit and the DFVE 36 CP1300A indoor air handler. We will determine the following information using the I/O manual, assuming the liquid line is 3/8 and the suction line is 3/4, and all 90-degree elbows are long radius in this example. You'll see with the liquid line lengths shown here, our total line set length is 42 feet 5 inches. You'll also see the vertical line elevation using the 12-foot 4 rise, the 8-inch rise, and the 8-inch rise again at the indoor unit. We see that we have a total vertical elevation of 13 feet 8 inches. Also notice that the suction line has a reverse trap that rises above the top of the indoor coil. We see by the I/O manual and the data tag on the outdoor unit, the factory charge is 162 ounces. By using the I/O manual and calculating the total liquid line length, we see the additional charge is 14 ounces, which gives us a total charge of 176 ounces, with the target subcooling of 11 degrees Fahrenheit. Commissioning. The startup screen is displayed when you apply power to the thermostat. The welcome screen displays preferences to choose from. The version of the thermostat is displayed on the equipment type screen. Selecting setup options allows you to factory reset the thermostat. Begin Setup walks the installers through the entire commissioning process to ensure the system is configured properly and ready for the homeowner to use. It enables access to any settings, remembers settings as they are entered. Individual may stop and restart as needed. The screens are populated based on the model numbers of the equipment matched to a database of device configuration settings. Full setup. Startup. Tapping Begin Startup starts the 5-step startup process. Communication, personalization, equipment setup, system optimization, and preferences. Note, all steps must be completed and reviewed before completing setup to ensure the system is configured properly and ready for the homeowner to use. For detailed menu settings, go to https://daikin1.com/smartthermostats/OnePlus/pros. Step 1. Communication. Configures communication networks. Select Home Wi-Fi to search for networks. With Wi-Fi configured, the system can check the software version and update software to the latest version automatically. Note: the wireless router must be password protected. Compatible with 5 GHz routers which support 2.4 GHz. Equipment type displays the equipment selected on startup. The thermostat must be updated to version 3.5.4 or later for R32 software compatibility. Step 2. Personalization. Tapping the Personalization tab allows you to edit the default information. Personalization displays language, large font selection, time and date. If Wi-Fi is connected, date and time are set automatically. Thermostat name and degree units. Step 3. Equipment setup. This displays equipment found by searching the communication network or by adding or removing equipment and accessories from the preset list. The unit that is identified determines the list of configurations that will be displayed. View the unit specifications. Configure cool settings, heat settings, heat pump settings, humidifier relay, and heater kit. Cool settings. Cool airflow trim. Airflow may be adjusted from -15% to maximum. High airflow is adjusted from -15% to +15%. Adjusting your intermediate and low airflow trim settings lower can help improve dehumidification. Before adjusting airflow trim settings, verify the duct system and airflow requirements are met. Refer to the I/O manual for restricted airflow combinations. Cool profile. The system offers several blower ramping profiles for cooling. These profiles may be used to enhance cooling performance and increase comfort level. Cooling airflow profiles. Refer to the installation manual. There are 4 cooling airflow profiles available. All residential inverter systems are factory set for Profile D. Profile D ramps up to 50% of the demand for 1/2 of a minute, then ramps up to 82% of the full cooling demand and operates there for approximately 7.5 minutes. The motor then steps up to the full demand airflow. Profile D has a 1/2 minute at 50% airflow off delay. Cool settings. Dehumidification. The thermostat reads the indoor humidity level. Target humidity set point is adjusted once the system has been completed. The thermostat controls the humidity level of the conditioned space using the cooling system. Dehumidification is engaged whenever a cooling demand is present and humidity levels are above the target level. Circulating fan output is reduced. System runtime increases. Dehumidification demand is controlled based on the humidity differential between the set point and the detected humidity. If the room temperature is 2 degrees Fahrenheit higher than the set temperature, dehumidification demand will be sent to prioritize to room temperature control. Dehumidification performance. The performance can be improved by changing the dehumidification profile in cooling settings to A, B, or C. The settings can be changed from the dehumidification setting menu at any time when required. The minimum compressor speed will be locked depending on the selected profile. The operating range limitation will be unlocked when the humidity reaches the set value. There must be a call for cooling and a demand for dehumidification. Heat settings. Heat airflow trim. The user can change the airflow trim at high, intermediate, and low compressor speed. Airflow may be adjusted from -15% to +15%. Refer to the I/O manual for restricted airflow combinations. Note: lower heating speeds will reduce electrical consumption, lower operating sound levels of the blower, and increase the outlet air temperature delivered to the home. Heat settings for the heat pump. Defrost heat. You can select the outdoor temperature for backup heat to activate during defrost, at or below 30 degrees Fahrenheit to 65 degrees Fahrenheit, or on or off. Defrost interval. Every 30, 60, 90, or 120 minutes is selected from the thermostat menu. If the defrost sensor drops below the freezing temperature during the selected interval, the outdoor unit printed circuit board initiates defrost cycle. The outdoor fan and compressor will de-energize. The reversing valve switches from heating to cooling operation. The outdoor printed circuit board communicates to energize backup heat if enabled. The coil and defrost sensor temperatures are monitored every 5 seconds. When the coil temperature reaches 54 degrees Fahrenheit and the defrost sensor temperature is greater than 43 degrees Fahrenheit for 30 seconds, defrost operation is terminated. Defrost operation. Intelligent defrost. If it takes longer than 5 minutes to reach the target coil temperature, then the initial time interval you selected will be shortened for entering the next defrost mode. If it takes less than 5 minutes during the defrost mode to reach the target coil temperature, then it will lengthen the interval before entering the next defrost mode. This is called intelligent defrost. Auxiliary heat logic. For dual fuel operation only, you can select to prioritize efficiency or comfort. Selecting prioritize efficiency, the selected balance point will be a hard lockout. This will give you heat pump operation above the balance point, furnace operation below the balance point. Selecting prioritize comfort will cause the system to run with the logic listed above. Add equipment. The Daikin 1 thermostats are compatible with multiple accessories: auxiliary heat source, humidifier, dehumidifier. You can install the auxiliary heat source, humidifier, and dehumidifier by using auxiliary terminals. UV light, electronic air filter, HEPA filter, EWC zone board, or D24V gateway. Zoning control accessory board in an air handler, 120 volt AC accessories. R32 leak detected, alarm activated. All relays on zone mitigation board switch. Power to accessories is removed. Mitigation mode ends, relays switch back, and accessory has power again. Terminals are designated TB11, control common, TB12, control normally open, TB13, control normally closed. And the accessory 1 power source terminals is 120 volt AC. Zoning control accessory board DFVE using auxiliary contacts on Daikin 1 24 volt accessory. R32 leak detected. Alarm activated. All relays on zone mitigation board switch. Power to accessories is removed. Mitigation mode ends, relay switch back, and accessory has power again. Terminals are designated TB11, control common, TB12, control normally open, TB13 control normally closed. The wiring that you're seeing is field supplied outside of the air handler cabinet. Auxiliary heat source. Selecting Add Equipment will allow you to configure an auxiliary heat source. This is not for setup of a heater kit for backup electric heat. This would be for boiler, duct heater, boiler with hot water coil. Auxiliary heat source is the only control option for an AC-only outdoor unit. Auxiliary heat setup on Daikin 1 Plus. Secondary heat settings. The control section will allow you to adjust the settings such as lockout and secondary heat activation temperature. Emergency heat mode will appear as a system mode when connected to heat pump units and can be used to directly turn on the auxiliary heat source if enabled. T-on, T-off control. T-on and T-off provide an alternative control method to have the main AC or heat pump control the auxiliary heat source using its PI control algorithm. T-on, T-off is the only control option for AC-only outdoor units. If the indoor unit is a gas furnace or is an air handler with a heat strip, these heat sources will be controlled around the heat set point by the demand-based algorithm. The auxiliary heat source will be controlled independently. Auxiliary heat control. When the heat pump is the primary heat source, the heat pump lockout temperatures are adjustable from -20 degrees Fahrenheit to 65 degrees Fahrenheit in 5-degree increments. The default setting is 15 degrees Fahrenheit. Auxiliary heat lockout temperatures are adjustable from -10 degrees Fahrenheit to 75 degrees Fahrenheit in 5-degree increments. Default setting, 50 degrees Fahrenheit. Auxiliary heat demand. T-on differential is adjustable from -7 Fahrenheit to -3 Fahrenheit in 1-degree increments. Default, -3 degrees Fahrenheit. T-off differential is adjustable from -4 degrees Fahrenheit to 1 degree Fahrenheit in 1 degree Fahrenheit increments. Default setting, 1 degree Fahrenheit. This graph showing the set point, default heat pump settings, heat off demand to heat on demand, and default heat pump with auxiliary, showing the auxiliary demand off and auxiliary demand on settings. When auxiliary heat is the primary heat source, heat pump lockout temperatures are adjustable from -20 to 65 degrees Fahrenheit in 5-degree increments. Default, 15 degrees Fahrenheit. Set point differential can be set at -9, -7, -4, and -2 degrees Fahrenheit. Default, -2. Heat pump demand. T-on differential can be set at -1 or -2 degrees Fahrenheit. Default, -1. T-off differential is fixed at 1 degree Fahrenheit. Humidifier relay. Air handler. For the setup for a humidification functionality, the accessory terminals have 3 operational modes. 1. On. Humidifier is enabled during a call for heat. During a call for heat, the accessory relay will close if there is an active call for humidification from the thermostat. 2. Off. Humidifier remains off. Relay is open. 3. Independent. The humidifier will cycle with any active call for humidification from the thermostat independent of a heat call. Relay is open during cooling operation. This allows the user to select one of 4 fan speeds: 25, 50, 75, and 100%. Fan speed is used when the system is in an idle state and a call for humidification is made by the thermostat. Zoning control accessory board, air handler for 24-volt accessory. R32 leak detected. Alarm activated. All relays on zone mitigation board switch. Power to accessory is removed. Mitigation mode ends. Relays switch back and accessory has power again. The terminals are designated TB11, common, TB12, normally open, TB13, normally closed, with a field-supplied transformer mounted outside the air handler cabinet. Humidifier relay, 2-stage furnaces, non-A2L. Connect humidifier to the powered contact HUM terminal, 120-volt AC output. In equipment setup, select the gas furnace to turn on the heat humidifier relay. Set the desired humidity set point under the Comfort tab in the settings after completing the setup. The auxiliary terminals only need to be set up if the control wiring for the humidifier is run directly to the Daikin 1 thermostat. On modulating furnaces, non-A2L, connect the humidifier to the dry contacts HUM1 and HUM2 on the furnace printed circuit board. Set the desired humidity set point under the Comfort tab in the settings after completing the setup. Here is an example of a humidifier and electronic air cleaner connections. Accessory power on, R32 leak detected, alarm activated, all relays on zone mitigation board switch, power to accessories is removed, mitigation mode ends, relays switch back and accessory has power again. Auxiliary alarm, air handlers. The control is equipped with 2 auxiliary alarm terminals. Alarm terminals TB4 and TB5 are typically utilized in series with a condensate switch, but also can be used with compatible CO2 sensors or fire alarms. The auxiliary switch is normally closed. It opens when the alarm occurs. Note, errors will be maintained in the equipment's fault history. DM80TC and DM96TC gas furnaces. The control printed circuit board is equipped with 24-volt auxiliary alarm input, the purple and white wire attached to pin 6 of the 15-pin connector. It's typically used for condensate switch wiring, but could be used with compatible CO2 sensors or fire alarms. Can be activated or deactivated from the thermostat. On the DM97MC gas furnaces, the jumper may be removed between auxiliary in and auxiliary out and wired to a normally closed float switch. The switch must be closed for normal operation. If open, the integrated furnace control will terminate operation. System optimization. System test. Running a system test is required for the inverter units before proceeding to complete the setup. Thermostat must be calibrated. The test needs to be completed without any errors. When the tests are completed, the Run Test screen is displayed. System test is complete only when the display code E11 notice clears from the 7-segment display on the heat pump or air conditioner control module. System must be in off mode while running the tests for the E11 code to clear. Charge verification mode. Charge verification allows for a system operation approximately 50% capacity for 1 to 2 hours. The system will stop when the Stop Test button is pressed or once the test is complete. Note: for proper charging of the system, please see Equipment Installation Manual. Verify refrigerant charge. Subcooling. Before starting charge verification test, confirm the indoor airflow and static pressure are within tolerance before verifying subcooling measurement. If the ambient temperature is between 65 and 105 degrees and the unit is operating at 50%, add or remove refrigerant per the chart as shown. If the system is not in condition after the first 20 to 25 minutes, a message will be displayed on the thermostat stating the reason. If the outdoor ambient temperature is less than 65 degrees Fahrenheit or more than 105 degrees Fahrenheit, thermostat display will notify you of that, and charge verification will not be allowed. Weigh in the charge. Subcooling value displays on the 7-segment display only during the charge mode. System optimization. Refrigerant leak test. In this mode, the sensor will trigger an alarm, all components will shut down, and the blower will turn on. If you have a zone accessory board, ensure that all zone dampers open and any accessories turn off. Error history. The error history menu stores errors from the most recent to the least recent. Each error entry includes an error code and a timestamp along with the equipment type that generated the error, and a brief error description is displayed. Status. The status menu displays data pertaining to the selected equipment. The scrollable list can be accessed anytime by returning to the Installer Setup screen. Preferences. Deadband overcool. The overcool value is overlaid on the deadband, increasing the range to maintain the minimum cool heat differential of at least 2 degrees. It is recommended to set at least 1 degree of overcool for dehumidification purposes. Powerful heating mode. Powerful heating enables the system to increase supply air temperature when demand is low to satisfy comfort. This mode decreases indoor CFM and may increase compressor speed. Note: powerful heating mode is off by default. It can be activated through the thermostat user menu. Boost mode. Boost mode allows the compressor to operate at a higher RPS or revolutions per second than factory maximum. Maximum RPS value is hard-coded into the software and cannot be changed. Cooling boost mode outdoor activation temperature can be adjusted in the boost mode menu. Boost mode will operate after the ambient temperature increases beyond the selected activation temperature and the compressor has achieved its maximum RPS. Heating boost mode is enabled and disabled by selecting on or off. On thermostats, you may select the maximum RPS offset. This allows you to adjust plus or minus 10 revolutions per second from the factory maximum RPS. Duct static pressures. Checking duct static. Refer to your rating plate for the maximum external static pressure, or ESP. Incorrect external static pressure may cause excessive temperature rise, motor stress, duct stress, reduced performance, unwanted condensation, etc. Checking duct static. The positive static pressure is measured on the furnace at the supply air outlet and must be read between the furnace and the cooling coil. On the air handler, MBVK, at the supply outlet. The negative static pressure is measured on a furnace at the return air plenum and must be read between the furnace and the air filter. On an air handler, at the return air plenum and must be read between the air handler and the air filter. On the MBVK, between the modular blower and the cased coil. Be careful to not damage the components within the cased coil. Static pressure on a gas furnace and AC coil. The design static of most furnaces is 0.5 inches of water column. Use a manometer to measure the static pressure of the furnace only. Supply side is measured between the heat exchanger and the evaporator coil. Return side is measured between the blower wheel and the air filter. Static pressure on a single-piece air handler. On a single-piece air handler, the evaporator coil is installed at the factory and is already considered in the static pressure calculation. Use a manometer to measure the static pressure for the air handler only. Measure static pressure of the supply duct at the outlet of the air handler. Measure the static pressure of the return duct at the inlet of the air handler. Static pressure on a two-piece air handler. On a two-piece air handler, the evaporator coil is not part of the air handler, so it must not be considered in calculating the static pressure. Use a manometer to measure the static pressure of the air handler's blower assembly only. Measure the static pressure of the supply duct at the outlet of the unit. Measure the static pressure between the outlet of the evaporator coil and the inlet of the air handler. Problems caused by high static pressure. Problems resulting from high static pressure. Reduced airflow. Limit or pressure switch tripping. Long term will shorten the life of the compressor, heat exchanger, motors, and components. Testing static pressure drop on individual components. You can see from this graphic that if your manometer is reading 0.4 inches of water column static pressure between the inlet and the outlet of the coil is dirty. It also shows if your magnehelic is reading 0.3 inches of water column or more across the air filter, then you have a restrictive or a dirty air filter. Startup checklist for Daikin FIT system. Included is a startup checklist. It's recommended that you fill it out completely and save it with your records. Dealer Edit. Navigating to Dealer Edit will allow you to access or revisit the installer setup screen. Dealer Navigation. Acknowledging the prompt enables you to tap the Learn More icon in the top right corner. The icon displays the installer code, giving you access to the installer setup screens. Thank you for joining us for the Daikin FIT R32 Installation and Commissioning Technical Training Module, TRV 13.2. If you have any questions or need more information, please contact your local CAFRD Group Technical Service Advisor at one of these 12 locations.